Okay, so in probably a couple of your previous math classes, you've gone over these little uh, acronyms to refer to various triangles, right? Like SSS stands for side, 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 ASA, angle, side, angle. So you use these when proving that triangles were congruent. Okay, so now only some of these work, right? These are like all various combinations of A's and S's, but not all of them prove congruence. Okay, so it's probably been a while. So I'll tell you the ones that do prove congruence are side, 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 meaning for two triangles, all three pairs of sides are congruent. SAS, meaning if you have two pairs of sides and the angle between them, the triangles are also guaranteed to be congruent. Angle, side, angle. If you have two angles and the side between them. Okay, and side, angle, angle, or sometimes you see it the other way, angle, angle, side. Okay, so for if you're given those three specific measurements, there is only one possible triangle with those measurements. Okay, so let me just quickly try to show you a demonstration. Let's say I wanted you to form a triangle with this length, and this length. Okay, there's actually only one way to do it. So even though I don't tell you a single angle, so let's just see. So like, for example, if I put this at the bottom and I put this one over, like if I try to make it an obtuse angle, this angle, this side is not nearly long enough to connect it, right? So that's not going to work. So I know this one has to like tilt in. Okay, and then over here, right, it still doesn't quite connect. So I need to like alter this a little bit. Oh, sorry. Right, so you can see that there's not infinite ways to make the triangle work, right? It's got to be like perfect. Okay, so I'm getting closer, right? I'm not going to take the time to do it, but yeah, there's only one way to make the triangle fit. Okay, on the other hand, angle, 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 and side, side angle. These three, or these pairs of three measurements are not enough to uniquely identify a triangle. Okay, so for example, what if I told you I want you to draw a triangle with 360-degree angles? Okay, so this would work, right? But if you took that exact same triangle and doubled all the side lengths, right, it would also be a valid triangle, but this one would be larger, so they're not congruent anymore. Right, so just by having three angles, that doesn't mean I know what triangle you drew. There's many possible triangles that fit those measurements. Okay, so another thing to keep in mind is that for the given information, because like some of these have, these both have two A's and one S, so how do you tell them apart? Okay, so if you look at this top left one, you're given this angle, this side length, and this other angle. Okay, so the rule is you basically have to go the shortest path. You can't go through empty space. Okay, so in order, you have an angle, a side, and an angle. So this is ASA. You cannot say, well, can't I do S, then A this way? You're not allowed to go through this big empty space. Okay, so again, this represents ASA. You're given an angle, a side, and then another angle. Okay, same thing with this one over here. You've got an angle, and a side. Okay, you cannot go ASA because you went through this empty space. Instead, you would have to go like this, SAA. Okay, so go ahead and take a second and tell me which three-letter description works for the other three triangles, please. Okay, so these are all sides, right? So SSS. These are all angles. So this would be AAA. And this one over here, you're given two sides and the what we call the included angle. So this one's side angle side. Okay, so our goal for these last three lessons of the unit are to be able to solve any triangle. Solve means find all missing side lengths and angle measures. Okay, so you might be thinking, well, haven't we done a lot with triangles already? Don't we already know how to solve them? Like, for example, if you look at this one over here, right? Like, can't we already solve this? Couldn't we say, for example, I don't know, cosine of 83 degrees is adjacent over hypotenuse? And the answer is no, we can't. So can anyone tell me why this is not a valid statement? Yes, Adam? Very good. Sine, cosine, and tangent are for right triangles. This is not a right triangle. There's no 90-degree angles. So we can't use cosine or any of the other ones at all. Okay, so up to this point, we do not have the tools to solve what are called oblique triangles. So an oblique triangle is a triangle that does not have a right angle. Okay, and that's unfortunate because most of our tools, like the Pythagorean theorem and sine, cosine, tangent, all require right angles. Okay, so how are we gonna do this? Well, first, let's review a few things that are true for all triangles, both right and non-right. So first, the triangle sum theorem. Okay, so the sum of the three angles of a triangle is always 180 degrees, right? That's something you've been using for years, but we'll continue to use it. So I just wanted to remind us of that fact. Okay, next we have what's called the triangle inequality theorem. So this states that the sum of the two shorter sides of a triangle must be greater than the third side. Okay, so this one will be very helpful to us to determine if our side lengths make sense or not. Okay, so let's make sure we understand the reason this is true. Let's say that I asked you to form a triangle with sides of 2, 4, and 10. Okay, so it's probably not exactly, but close enough. Okay, so how can we form a triangle with these measurements? Well, so let me just put the 10 at the bottom. Okay, so we know with a triangle, the sides need to connect, right? So if I put the 2 here and the 4 here, it's not even close to forming a triangle, right? Because the bottom side is so long that the 2 shorter sides don't have enough distance to meet. Okay, so that's why when you add these two together, it has to be more than the long side. Otherwise, that means, like in this diagram, the 2 shorter sides will never connect. Okay, and then lastly, we have what's called the opposite side theorem. Okay, so for any triangle, the longest side is always opposite the largest angle. Okay, and then the opposite, the shortest side is always opposite the smallest angle. Okay, so let's think about the reason this is true. Let's say that you had a very large angle. Okay, so that means, the sides of the angle are far apart. Well, now when you form a triangle, because the two sides split up so much, in order for those sides to connect, the opposite side has to be very long. Okay, now the opposite, if you have a very small angle, meaning that the things are close together, because the sides stay close together, the opposite side will not be that long. Okay, so these will be very, very helpful to us when we make sure our answers are correct. Right? We'll, in just a couple seconds, we can quickly verify, do the 2 shorter sides add up to more than the third side? And then is the longest side opposite the largest angle? Is the shortest side opposite the smallest angle? Okay, so we'll see a little bit later today how we can quickly use these. But do we have questions on anything before we continue? Okay, go ahead and turn to the second page then. Okay, so we are going to introduce, and we'll continue next time, something called the law of sines, S-I-N-E-S. Okay, so, I just told you that we're not allowed to use sine when it's not a right triangle. So how come we can do something called the law of sines? We'll see shortly. But let's go ahead and write this down first. Okay, so the law of sines is only useful for these situations. When you're given ASA, SSA, or SAA, okay, so we can use the proportion of the sine, that's why it's called the law of sines, the sine of an angle to its opposite side. Okay, so this will let us find all missing side lengths and angle measures, this thing called the law of sines. Okay, so what is the law of sines? So here we have a triangle that is clearly not a right triangle, right? You can see this angle up here is obtuse, it's more than 90. These two are acute, they're less than 90. So again, it seems like we can't do sine at all, but let's just go ahead and start. Let's label this bottom left vertex as capital A. The top one we'll call capital B, bottom right, capital C. Okay, and then if you recall, we name side lengths with the lowercase version of their angle, of their opposite angle. Okay, so angle capital A is over here. So this side over here we'll call lowercase a. Capital C is over here. So this one we will call lowercase c. And then the top angle is capital B. So the bottom side will be lowercase b in length. Because we're going to split this up, let's clarify that lowercase b is this entire bottom length. Okay, so again, right now we can't do sine of any of the angles because there's no right angle. So what we need to do is create a right angle. Okay, so how we're going to do that is from point B, we're going to draw what's called the altitude. So the line straight down that hits the bottom in right angles. Okay, so we now have two different right triangles. Okay, so because we split the bottom length B, just remember that this is not B and this is not B. But we also need a name for that line we drew in. So let's call it lowercase h for the height. Okay, so let's focus on this right triangle first. We can now do the sine of capital A. Okay, so again, ignore the rest of the triangle, just focus on the highlighted right triangle. So sine of angle A is opposite over hypotenuse. Okay, so h over c. Okay, we'll come back to that, but focusing on the other right triangle, we can also now do sine of capital C. Okay, so again, opposite over hypotenuse. Okay, so we have two different equations, and they both involve lowercase h. Okay, so let's try to get the h by itself. Over here, let's multiply both sides by c. All right, so, or c over 1, right? So these cancel out. So lowercase c times the sine of capital A equals h. And then over here, we would multiply both sides by lowercase a. Okay, so lowercase a times sine of capital C equals h. Okay, well, if both of these things equal h, then they must equal each other, right? So we can now substitute this into here, or I guess this part. Okay, so we have c times the sine of a, capital A, equals lowercase a times the sine of capital C. Okay, and then lastly, just to get this in a more useful format, we're going to divide both sides by lowercase a, lowercase c. Okay, so on the left side, the c's cancel out, leaving you with sine of capital A over lowercase a. And on this side, the a's cancel out, leaving you with sine of capital C over lowercase c. Okay, so this is what I meant earlier when I said we can use the proportion of the sine of an angle to its opposite side. Okay, so the sine of angle A and its opposite side, lowercase a, right? That's one ratio, and you set it equal to the c's also. Okay, and then if you, instead of drawing the height from B, you drew it from C, you could get the b's involved. Okay, so let's write the full law of sines over here. Okay, so sine of capital A over lowercase a, that's equal to sine of capital B over lowercase b, which is also equal to sine of capital C over lowercase c. Okay, so this equation has three parts, but all of them are equal to each other. Okay, so sometimes you'll use the A's and the B's. You'll use this part. Sometimes you'll use the B's and the C's. And sometimes you'll use the A's and the C's. Okay, so given any two of the letters, you can set them equal. Okay, so with that all in mind, let's go ahead and jump down here. Okay, so first of all, what type of triangle is this? You're given a side length, an angle, and an angle. So this is SAA. All right, so in order to use the law of sines, let's first label all their sides with their letter names. Okay, so again, opposite capital A will be lowercase a. Opposite capital B will be lowercase b. So even though that's already labeled as 7, go ahead and fill in that b equals 7. And then over here, this side will be lowercase c. Okay, so now we want to apply the law of sines to this. Okay, so which pairs of letters should we use? Should we use A and B, or B and C, or A and C? Well, if you were to use the A's, you wouldn't really get very far because you don't know capital A and you don't know lowercase a either, right? So you don't want two different variables. Okay, on the other hand, we know both angle B and lowercase b, so that's great. And then out of C, we know angle C, but we don't know lowercase c. Okay, but that's better than A. Okay, so we're going to use the fact that sine of capital B over lowercase b equals sine of capital C over lowercase c. Okay, so we're using the last 2/3 of the law of sines right now. Okay, so the part that we know capital B is 44 degrees. We know that side length lowercase b is 7. We know that capital C is 53 degrees. But we don't know side length lowercase c. Okay, so just leave it as the variable then. Okay, so in order to solve this, this is called a proportion. It's two ratios or fractions set equal. There's multiple strategies you can use, but I would use cross multiplication. Okay, so you only cross multiply when there's an equal sign between the two fractions. Okay, so this diagonal, you would multiply together 7 times the sine of 53 degrees. and you set that equal to the product of the other diagonal, c times the sine of 44 degrees. Okay, so something you guys should follow for the rest of this unit is never round until the very last step. Okay, so some of you might be tempted to turn the left side into a decimal right now. You don't want to do it because the variable c is not by itself yet. Okay, so the more often you round, the less accurate your answer is. So that's why we don't round until the very end. Okay, so how do we get that c by itself? Right now it's getting multiplied by the sine of 44 degrees. Remember, sine is a number. It tells you, opposite over hypotenuse, both of which are numbers. So you are allowed to divide by the sine of 44 degrees. Okay, so now we have the variable c isolated, meaning by itself. Okay, so here you would definitely need to use a calculator. So I do want to remind you that we've used both degrees and radians. Right now, our angles are in degrees. So you want to make sure that you're in degree mode. Okay, so for TI calculators, you should see DEG. For like Casio's, you should see the letter D in like a block at the top. Okay, so if you're in the wrong mode, for me, it's the DRG button, right? If I were in radian mode, I would go over here to degree mode instead. Okay, if you're in the wrong mode and you can't figure out how to get out, I'll tell you later. Okay, but for me, I'm gonna type in, sorry, what was it? It was 7 sine 53 degrees, close, divided by the sine of 44 degrees. Okay, so now we'll go ahead and round to the nearest hundredth, the second decimal place. The next digit is 5 or more, so we're going to round this up to 8.05. Okay, and let's go ahead and fill that into our diagram, right? So we think C is about 8.05. Okay, so we cannot use the Pythagorean theorem, by the way, to get the last side because this is not a right triangle. Pythagorean theorem only works for right triangles. Okay, so instead, we want to use the law of sines a second time. But we still have the same problem, right? If I were to do sine of b over b equals, or let's start over here, sine of a over a. Okay, we know b, capital B. We know lowercase b. But we still have two unknowns, right? Capital A and lowercase a. So we need to figure out one of them separately. Okay, so does anyone have an idea how we could find either angle capital A or side lowercase a? Yes, Helen? Okay, so good. Helen said that the angles have to add to 180. Okay, so whatever this angle capital A is, if you add the other two angles to it, you get 180 degrees. Okay, so the two known angles combine to 97 degrees. So when you subtract from the full 180, that leaves 83 degrees for angle A. All right, so now you are able to work with the A's. Okay, so you have to use the A's for sure because you're trying to find lowercase a, but should you pair it with the B's or the C's? In general, you should always use the exact numbers. Okay, so for the b's, these numbers they're nice whole numbers. Nothing is rounded. For the c's, we had to round this answer. Okay, so you should avoid using rounded answers. Okay, so let's pair the a's and the b's now. Okay, so now we're using the first 2/3 of the law of sines. Okay, we now know that capital A is 83 degrees. We don't know lowercase a yet, so leave it as the variable. Sine of B, we know is 44 degrees. Lowercase b is 7. Okay, so again, do not turn this into a decimal yet. You don't want to round until the variable is by itself. Okay, so we instead start by cross multiplying. A times the sine of 44 degrees equals 7 times the sine of 83 degrees. Okay, still don't use your calculator because you first want to get rid of this sine 44 degrees. Since it's multiplying the a, we can divide both sides by a. Okay, so now we're ready to use our calculator. Okay, so we can type in 7 sine 83 degrees all over the sine of 44 degrees. Okay, so this one, 10.00178,412. It actually would round to 10.00. Technically, you're supposed to put the 0.00 to show that you rounded to the nearest hundredth, not just the nearest whole number. Yeah, if you guys like in science, if you talk about like exactly sig figs, yeah, because if I just said 10, you might think it was like 10.4 and I rounded it down to 10, but actually it's much more exact than that. Okay, so let's fill that in as well. Okay, so it seems like we have all the sides and angles filled out, but now we want to quickly check through those 3 properties from the bottom of the front page. Okay, so with your calculator, you can do this in like literally 10 seconds combined. Okay, so first, do the 3 angles add to 180. Okay, so using our calculators, we say 83 plus 53 plus 44. Does equal 180, great. Okay, now the second rule. When you add the 2 shorter sides, is it more than the third side? So you don't even need a calculator for this one. 7 plus 8 something is 15 something, which is way more than 10. So that's good also, right? The 2 shorter sides have enough length to meet up. Okay, and then the third thing, you don't need a calculator at all. Is the longest side opposite the largest angle? And also, is the shortest side opposite the smallest angle? Okay, so based on our diagram, the longest side is 10. Is it opposite the largest angle? Yes. Okay, the shortest side is 7. Is it opposite the smallest angle? Yes. Okay, so all 3 properties check out, which is a good sign that we did it correctly. Okay, so before we continue, are there questions on any of this? Okay, so there's one last thing to do. We were also asked to find the area of this triangle. Okay, so there's a couple different ways to do it, but the way that I'm gonna use. Okay, so the area of a triangle is 1/2 times the base times the height. All right, this again is a formula that you've been using for years. The problem is, like before, the base and the height have to form a right angle. Okay, but we can use the exact same strategy we did above. Let's create a right angle in order to form the height. Okay, so I'm going to go ahead and draw in a vertical line, this time from A going down to B. Okay, so I formed two different right triangles, but it doesn't matter because they both overlap with the height, right? Both of them have the same height. Okay, so now would I rather use this triangle or this one? This one has a rounded side. This one has an exact side. Okay, so let's use this triangle. Okay, our goal is to find the height. Okay, so just focusing on this one, we're going to use this angle. We want to find the opposite side, and we know the hypotenuse. So opposite and hypotenuse, we should use sine. Okay, so sine of this 53-degree angle will be equal to the opposite h over the hypotenuse 7. Okay, let's get the variable by itself. To get rid of the divide by 7, we would multiply both sides by 7. Okay, and now that the h is by itself, let's go ahead and use our calculators. Okay, so this is about 5.59. Okay, so now we can use the area formula. Okay, so now base you got to be careful about, right? The base is the one that forms the right angle with the height. Okay, so here the base is 10.00. And the height we just figured out is 5.59. Okay, so 1/2 times 10.00 times 5.59. 27.75. And I'll just say units squared. Okay. All right, so let's set up this next one together, just so we're all working with the same thing. So it's pretty much always going to be A, B, and C. So if I don't tell you which letter is missing, or if there's a missing letter, it's whichever of A, B, and C is not there yet. Okay, so I always like to draw the longest side on the bottom. You don't technically have to. I just find it easiest to always do it that way. Okay, so let's draw a long side on the bottom. And then we have some very small angles, right? 13 degrees and 22 degrees are both very narrow. So maybe it'll look something like this. Okay, we'll call this angle C, giving us 13 degrees. We'll call this one angle A with 22 degrees. And again, the missing letter, it's always going to be A, B, C. So B is the missing letter. Okay, so now that we've set it up, please use the previous example and try to find all missing sides and angles, and then also find the area. Yes? Did you get the same height as me? Did you get the 5.59? Okay, so then the area of a triangle formula is 1/2 times base times height. So how do you know which side is the base? It's the one that forms a right angle with the height. Okay, so because this is the height, the base has to be this one. So I use 10 as the base. Okay, so yeah, 1/2 times the base of 10 times the height of 5.59. That's where I got this from. Oh, really? Let me double check my math. Oh, yeah, you're right. Thank you for catching that. Sorry. Okay. So once you fix that, go ahead and try to find all missing sides, all missing angles, and the area of this second triangle. Okay, so we can also use the law of sines for ASA triangles. All right, so given two angles and the side between them. Okay, so we should start the same way. We should start by labeling all the sides with their letters. So opposite angle A will be lowercase a. Opposite angle B, this one is lowercase b. Opposite capital C is lowercase c. Okay, so, do we use the A's and the B's or the A's and the C's or the B's and the C's? I don't know. Let's see what happens if we try the A's and the B's. Okay, we don't know capital A. We do know lowercase a. We do know capital B, but we don't know lowercase b. Okay, so we have two different variables, which means we can't do it, right? Because like if I told you x plus y equals 5, there's no way of knowing if it's 1 plus 4 or 2 plus 3 or 6 plus -1, right? With two variables and one equation, there's no way to solve it. Okay, so we can't do the A's and the B's. But the same thing is going to happen if we do the C's, right? The C's, you also only know one of them. Okay, so again, let me just show you real fast. If you try the A's and the B's, I just did that, A's and C's. Okay, exact same problem. Okay, so what about the B's and the C's? Right, no matter what, you always have two unknowns, right? So it seems like there's no way to do it. Yes, Gail? Okay, very good, yes. Kayla said you can find the missing angle by adding up the ones you know and subtracting from the triangle's total of 180 degrees. Okay, so we've already used up 164 degrees, which only leaves 16 degrees for angle A. Okay, but now that you know that, you can now do either the A's and the B's or the A's and the C's, right? Because now you know both capital A and lowercase a, so it doesn't really matter which one you do next. Okay, so, sorry. Okay, so I'll give you guys another bit of time to try to continue this problem. All right, so for this one, I went ahead and found the other side lengths. Remember, we always want to check though. So 16 plus 63 is 79, plus 101 is 180. That's good. If you add up the two shorter sides, you get 38.09, which is greater than 32.05. That's good. The longest side is opposite the largest angle. the shortest side is opposite the smallest angle. Okay, so all of those are good. Now, some of you were a little unsure about the height because this one's a little weird, right? The height is, in order to form a right angle with the base, the height would have to be outside the triangle. That is possible. You can find the height the same way. Okay, so again, sine is opposite over hypotenuse. So you could do sine of 16 degrees equals the opposite h over the hypotenuse 32.05. And then to get the height by itself, times 32.05 on both sides. Oops. Okay, so I got about 8.83 for my height. Okay, so I saw some of you drew a different height. Some of you did like this height from point B. That's perfectly okay. Your height will be different than mine, but our areas will come out to the same. Okay, but for me, I did the height from C. Okay, so then area would be 1/2 times the base of 29.09 times the height of 8.83. Oops. Okay, so that comes out to about 128.43 units squared. Okay, so again, if your answer is close to that, it's fine. You probably just used a different height than me, but that's okay. Okay, so let's jump to this last section. Okay, so this time, what are we given? We're given a side, and an angle. So this is an SSA triangle. And one important thing to notice here is that the one angle you're given in both examples is more than 90 degrees. It is an obtuse angle. Okay, so we're going to see why this matters, that it's an obtuse angle. But for now, just be aware that both of these use obtuse angles. Okay, so same problem as before, right? We can start right away because this is A, this is C, this is B. So we do have both parts of A, and we have one part of C. So we can't do anything with the B's right away, but we can use A's and C's. Okay, so capital A is going to be 97 degrees, lowercase a 22. Capital C is unknown, lowercase c is 19. Okay, so we want to get the variable by itself. Let's start by cross multiplying as usual. 22 sine capital C equals 19 sine 97 degrees. The 22 is a coefficient, which is multiplying the sine of C, so we divide both sides by 22. Okay, so the C is not by itself yet. The C is trapped inside the sine function. So this is where the first couple lessons of the unit come into play, right? We know that to undo sine, we do inverse sine of both sides. Okay, so this side cancels out. That's kind of the whole point. And then you can type the entire right side into your calculator. Okay, so inverse sine of 19 regular sine 97 all over 22. Okay, so let me show you how I would type that in. Okay, so again, inverse sine is above regular sine. So for me, it's second that button. inverse sine of 19 regular sine, 97 degrees, close up the regular sine, but I'm still in the inverse sine, divided by 22, and then close up the inverse sine. Okay, so you should get 59.00 degrees for angle C. Okay, and now that you have angle C, you can find angle B by using the fact that the three angles have to add to 180 degrees. Okay, so B would be 24 degrees. And now you can, I would probably use the A's and the B's, not the C's and the B's, because C you had to round. Okay, so 22 sine 24 over the sine of 97 rounds to 9.02. Okay, so again, don't forget, you should always check the three theorems. 97 plus 24 is 121, plus 59 is 180. The two shorter sides add up to 28.02, which is more than 22. The longest side of 22 is opposite the largest angle of 97. The shortest side of 9.02 is opposite the smallest angle. Okay, so all of that is good. And then you could find the area. But I'm not going to do that because I want to make sure you guys get a chance to try this part. Okay, so go ahead and give this last problem a try. Again, you'll have to draw the diagram yourself.